Hello and welcome to Chemistry Lesson 3.02, Average Atomic Mass. So what we're talking about today is why when you look at your periodic table, and we're going to go ahead and stick with lithium. We talked about the isotopes of lithium. So for our isotopes, we mentioned the lithium 6, we mentioned lithium 7, and we mentioned lithium 8, and it turns out lithium 8 is radioactive and it really doesn't stick around. And so when we look at the amount of isotopes that occur in nature, we're talking about these two. These are the two that occur in nature. Now, we said that this 6 and this 7 refer to atomic mass units. So we're talking about 6 AMU, we're talking about 7 AMU, where the mass of one proton or one neutron is 1 AMU. Actually, it's 1.6 times 10 to the minus 27th kilograms. So why don't we just use that? That's a really messy number. And so scientists kind of said, we're not going to work with this on a day-to-day basis. What we're going to say is we know there's 12 protons in carbon 12. So we're going to say that one atomic mass unit is 1/12 of a carbon 12 atom. And that's kind of where it comes from, but it's completely made up. Well, if you look at the periodic table, so go ahead and take a look at your periodic table and find the atomic mass for lithium. So on the periodic table, underneath, so it'll say Li, it'll say 3, so if this is your box, and then it's going to say 6.941. What? I thought my masses were 6 and 7. Well, it turns out that on the periodic table, we have a special average called a weighted average. Well, if I took a regular average, I would take 6 plus 7 and I would divide them by 2, and a regular average would be 6.5. But it turns out that 92.41% of all the lithium in the world is lithium 7, and only 7.59% is lithium 6. Well, to say that the average would be 6.5 would really be doing a disservice because most of our lithium is lithium 7. Only 7.59% of it is lithium 6. Here's another example of a weighted average. So let's do an example. You guys use weighted averages every 9 weeks. So you have a first 9 weeks grade, or every semester. You have a second 9 week, and you have an exam. So let's say your first 9 weeks grade is a 93%. Let's say your second 9 weeks grade is an 87%. And let's say you kind of bombed the exam. If you add these up and you divide by 3, that's going to give you an 80%. That means that a third of your grade came from this, a third came from this, and a third came from this. But that's not how your 9 weeks grades work. It turns out, if I remember correctly, I think 20% of your grade comes from the exam, 40% is your second 9 weeks, and 40% is your first 9 weeks. So what we actually do is we take these values and we multiply them by the decimal form of what they count for. So by 0.4, and that ends up being 37.2. We multiply 87 times 0.4, and that's going to be 34.8. And then I multiply 60 by 0.2, and that's going to be 12. And then I add all of these together, and that gives me 84. So we're talking about the difference between a C and a B. Because we do a weighted average, so this would be a regular average, and this is a weighted average. Well, we do the same thing with our elements. So let's do another example. Now I oversimplified the masses a little bit. So I have lithium 6 and I have lithium 7. The actual masses of lithium 6 are 6.015 AMU, and the actual mass of lithium 7 is 7.016 AMU. So the first thing you're going to do is to list out your isotopes. So here we have my isotopes. And we're going to multiply this by the percent occurrence in decimal. So we have to take this times. It turns out that we only have lithium 6 is 7. So it's going to be 7.59%. We have to change that to 0.0759. And the lithium 7 is present as 92.41%, but I need to change that to 0.9241. And when I multiply those out, I get 0.4565385. Notice how many decimal places I have here. This is the one time you don't want to overround. This becomes 6.48348. And when I add these together, I end up with 6.94 AMU. Actually 6.941. So that's where the numbers on the periodic table come from. We have a weighted average. So let's go back and recap. The periodic table is a weighted average of all naturally occurring isotopes. And to do this, the first thing I do is list my isotopes. The second thing I do is multiply by percent in decimal form. The third thing I'm going to do is add up, and then that gives me my total, which is what we see on the periodic table. All right, that is our lesson on average atomic mass and where the masses on the periodic table come from. Thanks for watching and have a good day.